KPI stands for Key Performance Indicator. I'm going to elaborate KPIs for VoLTE IMS network in this tutorial. KPIs are derived mathematically and are used to represent performance on network. These measurements will tell us how our network is performing. Good KPI value shows the customers are happy. The bad KPI values are showing customers are unhappy and dissatisfied, and they are also facing various issues. Here we'll cover all important KPIs which are used in VoLTE IMS network and their significance, use, calculation along with impact. Welcome to this tutorial of KPI and performance indicator for VoLTE IMS network. KPI stands for Key Performance Indicator, and KPI is a type of performance measurement that helps you to understand how your network is performing. In simple words, this represents the result and scorecard of your network. Every operator decides which set of KPI to be monitored based on the market situations and the network state. Here I am going to cover exhaustive mandatory KPI list, which is also used almost everywhere in the world. These KPIs are classified into various categories such as accessibility, retainability, integrity, availability, reliability, utilization, and mobility. For end-to-end VoLTE IMS network performance, you need KPIs and counters from all network elements responsible to provide VoLTE IMS service. This involves KPIs from SCSCF, TAS, which typically governs the signaling and call routing function. Similarly, KPIs of SBC and PCSCF will provide you insights of user plane which carries actual voice path. You can see quality of voice payload traffic such as MOS, mute call, one-way calls by looking on these SBC KPIs. Few operator uses external probes to get these SBC KPIs as well. On other hand, you also need to see KPIs of packet core and radio, which plays vital role in maintaining user mobility and dedicated bearer used for VoLTE IMS service. I'm going to cover enough material on VoLTE KPIs for general understanding. However, you can refer to 3GPP specs TS32454 and TS32409 and GSMA IR42 for advanced studies. Pay attention, as now you will see the real KPIs which are used for VoLTE IMS network. The first one is the TAS KPI, which provides a clear insight on the signaling related KPIs such as CSSR, which is call setup success rate, CST, which is call setup time, MST ACD, which is average call duration or mean holding time. The second one is SBC KPI, which gives us plenty of user plane KPI related with speech quality such as MOS score, such as mute call, RTP packet loss, and one-way calls. This one is S gateway P gateway KPI, which gives us bearer specific intelligence and KPIs. The next one is MME KPIs, which provides us attach mobility and paging specific performance such as VoLTE ASR, VoLTE attach success rate, VoLTE PSR, VoLTE paging success rate, and dedicated bearer activation success rate. The last but most critical are the radio KPIs, which are provided by eNodeB. These covers VoLTE call drop rate, SRVCC success rate, handover success rate for S1 and X2. Let's understand these KPIs in detail moving ahead. We'll start with detailed understanding of VoLTE control plane performance KPIs. These are generated by PCSCF and TAS. PCSCF KPI is RSR, which stands for registration success ratio. The second is the TAS. The TAS generates rest of KPIs such as CSSR, call setup success rate, CST call setup time, MST ACD, average call duration. RSR, registration success rate. This is a key KPI which is used to depict the probability of UE successfully registering to IMS network. If this KPI is degraded, customers will not be able to use VoLTE services due to failure in registration. RSR is calculated as a percentage of SIP registration request going to be successful. Once registration is successful, the IMS network will reply back with 200 OK message back to UE. Please note, the first SIP register request will always fail with error 401, which is part of call flow. Refer my another tutorial on SIP registration for more details on the same. While calculating RSR, we exclude and ignore 401 failures. The RSR is measured in percentage. The healthy value of RSR is 99% plus. This KPI is categorized under the family of accessibility KPIs. The source of this KPI is PCSCF. However, it can also be generated by SCSCF. Here is actual call flow where request goes all the way from UE to PCSCF to IMS core and 200 OK response is tagged as successful. CSSR is our second important KPI. CSSR tells you how easily users are able to make receive calls on VoLTE network. CSSR stands for Call Setup Success Rate. This is calculated separately for outgoing calls and incoming calls. The CSSR indicates the probability of successful calls initiated or received by the user. With low CSSR, customers will not be able to use or make calls on VoLTE network. Outgoing or MO call CSSR is calculated as a percentage of calls able to use network without any problem. Here we count call failed due to user behavior such as busy, not reachable, etc. Also in the normal call ending or success. Calls failed due to network issues. Specifically, network issues will be treated as failure and they will degrade CSSR. CSSR is measured in percentage. The healthy value of CSSR is 99 plus. This KPI is categorized under the family of integrity and retainability KPIs. Typical source of this KPI is TAS. However, this can also be generated by PCSCF. Here is the actual call flow which tells you the request is going through the handset and the response is coming back from the IMS network. The third critical KPI in IMS VoLTE network is CST or call setup time. CST is the overall length of time required to establish a call between the users. CST is the time between the start of the call and the moment the phone of the called party starts ringing. In other words, CST or PDD is considered as the time required for a call to pass through the network and reaches a B party user. This is calculated as a difference between the ringing time to the invite time. High CST will lead to delays, silence period before the ring, and high CST will deteriorate the user experience. Now let's understand the factors which can deteriorate the CST or call setup time. The first factor will be the B party is not in VoLTE. Now since B party is not in VoLTE, it will be latched in 2G or 3G network. In 2G and 3G networks, the call setup time is higher because a typical setup time for the call is 5 to 7 seconds in such scenarios where CSFB is used. The second possible reason of high CST could be like most of the B parties are sitting idle and they need to connect with paging required for every incoming call. The third possible reason could be the low coverage on the B party side. The fourth possible reason could be the congestion on B party radio or network. The fifth possible reason could be the high retransmission and high latency in the networks. The CST is measured in seconds. The healthy value of CST is less than 2.5 seconds. This KPI is categorized in the family of the integrity and retainability KPIs. Typical value of this KPI comes from the TAS. Now let's start MHT or ACD. They both are one and the same thing. MHT stands for mean holding time and ACD stands for average call duration. ACD or MHT is the average length of an answer call made over the network. This KPI falls under the family of control plane but reveals a very important information about the user plane. Let's take example. If the average call duration in the network have reduced, this specifically means the calls are being answered but there is some issue with the speech path. The users are disconnecting the call much earlier. Low ACD specifically means either the calls are getting mute or there is a one-way speech or there is some problem with the voice quality which is leading users and forcing users to disconnect the call much earlier. Wow, here is the bonus tip for you. Monitoring clear codes generated by the TAS is the best way to know the health and the pulse of a network. By definition, a clear code is the identifier code and this tells you the reason why the call is being cleared. This not only tells you about the internal network call failures, but also highlight the failures which are happening outside our network, which are happening in other network, maybe in the international domain, the national domain, or the POIs. Clear code or end of selection reports depicts the possible reason for failure of call. This is a complete list of course codes which tell us exact reason why the call have failed. Let's take example. If we see a sudden spike in CC34, which is no circuit channel available, this shows congestion in the network where calls are not able to move ahead. Benefits of using the clear code based monitoring. It provides complete check on outgoing calls made by the user for both external and internal failures. It detects the failure at a very early stage. Any major outbreak of clear codes gives us alert on the network outage. You can also get the list of clear codes from the GSMA specs 0408 Annexure H. Let me take some example of the clear codes like unallocated number, no route to a transit network, no route to destination, operator determined barring, normal call clearing, user busy, no user responding, no answer from user, subscriber absent, call rejected, number changed, destination out of order, invalid number format, so many of them. Now we will cover VoLTE user plane performance KPIs. Pay attention, these are user plane performance KPIs. The user plane KPIs are generated by the SBC or PCSCF or external packet capture probes deployed in the network. There are 4 critical KPIs which are we going to cover. The first one is the mute rate. The second one is the MOS score. We also call it as MOS. The third one is the RDP packet loss. The fourth one is one-way calls. The first critical user plane KPI is VoLTE mute rate. VoLTE mute rate is a measurement of calls where calls are getting mute in both direction. Going by formula, this is percentage of calls muted. That is, the samples greater than 2 or 5 seconds where RTP loss is detected in both direction. This value of RDP packets missing varies from 2 to 5 seconds from operator to operator. Unavailability of packets for 2 seconds is very aggressive and the 5 second is bit relaxed. This KPI is measured in percentage. The healthy value of mute call is less than 1%. The mute call KPI is categorized under the family of VoLTE service integrity, which is voice quality. This KPI is generated in external probes monitoring or SBC. The second most important metric is mean opinion score. This is also called as MOS. MOS or mean opinion score is a measure of voice quality. MOS have been used in telephony for decades as a way to assess human user opinion for the call quality. A low MOS score will tell us the speech quality is bad. MOS is expressed in numeric from 1 to 5, 1 being the worst and 5 being the best. MOS is very subjective and it is based on figures that results from what is perceived by the people. The value of 5 depicts the voice quality is perfect. It's like face-to-face conversation. The value of 4 tells us the call quality is fair but having some minor quality issues. This is supposedly the range of all the cell phones. The MOS value of 3 is annoying. The MOS value of 2 is very annoying. It's nearly impossible to communicate at MOS value of 2. The MOS value of 1 is telling us there is no communication. It's impossible to communicate with MOS value 1. Our target value should be better than 3.5 and this is measured by SBC typically. By its very name, opinion, the MOS or mean opinion score was very subjective measurement used to test the listener's perception of the voice quality and the clarity of the communication. During the measurements, all factors are taken in account such as listening quality, the transmission quality and the conversational quality. It's important to understand that the MOS score is measured on the relative scale built on variety of factors that can affect the voice quality. Because of this, there are many factors that can affect the MOS score that would not be the factor of regular phone line. The factors includes the bandwidth, the jitter, the latency, the packet loss, and the codecs. Now let's discuss VoLTE RTP packet loss. VoLTE RTP packet loss is another important KPI which measures the percentage of RTP packets lost in uplink or downlink direction. High packet loss will lead to mutes, one-way talk, call drops, bad quality, garbled voice. In total, this problem is mother of all the evils for bad quality on VoLTE IMS network. RDP packet loss is measured in percentage. The healthy value is less than 1%. This KPI is categorized under the family of VoLTE service integrity. This KPI is generated in SBC or packet capture probe. The last one is one-way call. Just like mute calls, this is a muting of a call in one direction, but not in both direction. Going by formula, this is percentage of calls having no voice RTP packets for 2 or 5 seconds in either upstream or downstream direction, but not both. Now let's discuss other KPIs being generated by the packet core network. There are two nodes which generates these KPIs. The first one is the MME, the second one is the S gateway or P gateway. MME generates the counter KPIs which are associated with mobility and attach. The MME gives you VoLTE attach success rate. MME gives you VoLTE paging success rate. MME gives you dedicated bearer activation success rate. While S gateway or P gateway gives you IMS IP pool utilization, S gateway P gateway also gives you create bearer success rate for VoLTE. Now let's quickly understand the first two packet core KPIs which are critical for us. The first one is the VoLTE attach success rate. This is the percentage of PDN connect request responded successfully by the MME for IMS APN. This is equivalent to attach success request and response. The second one is the VoLTE bearer activation success rate. This is again the percentage of create session request getting successful for VoLTE IMS APN. Now is the turn for VoLTE PSR. PSR stands for paging success rate. VoLTE paging success rate is a very critical and a phenomenal KPI. The VoLTE PSR is a rate of successful page responses to first and the repeated page attempts which are made on QCI 5. As you are aware, we are using QCI 5 and QCI 1 and 2 for VoLTE. Paging success rate is just like any paging request which is used to trace down the user sitting idle out there in the field. For every incoming call to VoLTE user, which is actually idle, the paging is sent by the MME to user on QCI 5 so that SIP messages for incoming call can be sent to the user. Low VoLTE PSR means the user will not be able to receive VoLTE incoming calls. In case of paging failure, TADS will happen and the calls will be sent on the CS network. This uses CS fallback technology for sending the calls on underlying 3G networks. More number of TADS will hint us problem with the VoLTE paging. Now is the turn of VoLTE IMS IP pool utilization. Just like Internet APN, this is IP pool allocated to IMS APN as well. For any dedicated bearer establishment of VoLTE services, IP is allocated by the P gateway from this IP pool of IMS APN. In case IP pool utilization is 100%, IMS VoLTE users will not be able to get IP allocated for IMS APN and will not be able to register to VoLTE services. Thereby, VoLTE user will not be able to use VoLTE network if IMS IP pool utilization is 100%. We can allocate both IPv6 and IPv4 IP pool for users. The radio network eNodeB is also generating few very critical KPIs which are used for overall health of VoLTE IMS network. These KPIs are, the first one is the call drop rate. This is measured in percentage. This tells us the percentage of calls which are getting dropped abnormally. This is calculated on QCI 5 bearer dropped abnormally. The second one is the SRVCC success rate. This is also measured in the percentage. This tells us the percentage of calls successfully transferred with SRVCC from VoLTE to 2G 3G network once user is moving on low LT coverage area. Handover success rate. Handover success rate on S1 and X2 is a key to mobility services for Volti. This is measured at E Note B. With this, our KPI journey is complete. Hope this will bring much more value to you and give you a better understanding on Volti performance. Thank you. If you want to download this PPT or video, please visit my website. It's telecomtutorial.info. Hope this video presentation is useful for you. Please feel free to like, dislike, comment and share. Please subscribe to my YouTube channel for more technical